Structure and properties of alcohols. Alcohols are organic compounds that contain a hydroxyl group. Any ROH is an alcohol, like ethanol. The reason so many college students have a social life. You can also have cyclic alcohols like cyclopentanol. And then, of course, there is grandisol, the sex pheromone of the female boll weevil. Oh no, I'm sorry, the male boll weevil. Here's chloramphenicol. It's an antibiotic. It's got two hydroxyl groups. It is a diol. Here's cholesterol. It's got lots of chirality centers. And cholecalciferol. Your body makes this when your skin is exposed to ultraviolet light. This alcohol is known as geraniol. It's got a pleasant odor, and it can be found in geraniums and roses and perfume. Here's dopamine. It's a special kind of alcohol called a phenol. Phenol is benzene with a hydroxyl group. Phenols share some properties with alcohols and have some properties to themselves. They tend to be quite a bit more acidic, like millions of times more acidic than alcohols. This, for instance, is a popular phenol. I don't know where that comes from. Have you ever been pepper sprayed? It hurt because of the capsaicin. I got pepper sprayed once. It sucked. Just like everything we've done, the first step in naming an alcohol is to identify the parent chain. This includes the carbon that the OH is attached to, not necessarily the longest carbon-carbon chain in the molecule. Right, so if it's not an alcohol, we're used to just using the longest carbon-carbon chain, but now, just as it was with alkynes and alkenes, the parent chain is the longest chain that includes this particular functional group, and in this case, it's the OH group. So, even though the longest carbon-carbon chain here has 1, 2, 3, 4, 5, 6, 7, 8, the parent here is hexanol, because the longest chain that includes the OH group only has 6 carbons. Step 2, as always, is to identify and name the other substituent. Then you're going to assign a locant and a prefix to each substituent, and the carbon that is alpha to the hydroxyl group gets the lowest locant. It takes priority over anything else, even a double or triple bond. Here we can see that the correct way to name this molecule is to number left to right, so that our parent is heptene 2-ol. Right, because you want to make sure that the alcohol, the OH, gets the lower locant than anything else. The OH has the highest priority. Step 4 is to list the numbered substituents before the parent in alphabetical order, and of course you ignore prefixes unless it's iso when you're doing the alphabetizing. Also, you can put the locant for the hydroxyl before the parent name or just before the OL suffix. So for this molecule here, we number left to right. So the parent is hept1-ene 2-ol. The locant 6 is the lower of the two sp2 hybridized carbons, and the locant 2 is for the alcohol. And since we have these two functional groups, both the ene and the ol, in this case, we want to put the locant for the alcohol just before the suffix. Usually it works either way. And then we've got 3 methyl groups. So 5,5,6-trimethyl hept 6-ene 2-ol. 6 ene 2 ol. 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 6 ene 2 Now you try one. Pause the video while you work, and then when you're ready you can unpause it to see the solution. So we number 1, 2, 3, 4, 5, 6. So the parent is hexanol, and the OH is on carbon number 3. So 3-hexanol is an acceptable name, or we could put the locant in between the N and the O, like this, to get hexane 3-ol. Phenols are always named with the phenol as the parent. So this compound on the right has a nitro group and a chloro group, and we number clockwise because that gives us lower locants. So 4-chloro-2-nitrophenol, and chloro before nitro because A, B, C, D, blah, blah, blah.